Welcome back. If once you have these markers on the chromosomes, right, you can look at figure 7.3. It says assembling clones in a clone contig. Remember earlier on we said that fragments of DNA are being chopped. Let's just assume that you are able to take one chromosome out, one chromosome, chromosome 7 for argument's sake, and then you are able to chop it up, and then you're able to clone them. But because they are chopped up and then they are all jumbled up, you need to order them, the clones, again, like this, like so, right? Let's say, for example, between this region A and B, right, you have all these clones, you have all 21 clones, and you want to order them up. Remember, if you already have the landmarks, right, so that means you check clone number 1, what are the landmarks there, clone number 2, and then you find regions that overlap. All right, so this is the use of having this STLs, the markers, and they allow you to put the clones together and then assemble them into what you call a contig. Contig comes from the word contiguous, and it refers to overlapping collection of overlapping clones. What is clone fingerprinting? Well, if you know what is human DNA fingerprinting, not the normal thumbprint, but fingerprinting is you have your DNA, and it is you cut your enzyme, you cut your DNA with enzymes, and if you run it on gel, all right, if you have two different individuals' DNA and they cut the same enzymes, there are polymorphisms. There are certain sites that may be present on one individual and not the other, and vice versa. So the other person may have a site that is not present on person number 1. All right, and because they vary in terms of the presence or absence of the cutting site, that means the fragment length will also be different. And this forms the basis of restriction fragment length polymorphism. And this has been the basis of one of the earliest fingerprinting methods. You take an individual, you cut with an enzyme. Each individual is expected to have unique bending patterns. You may use one enzyme, you may use 2 different enzymes or 3 different enzymes, or you may use individual enzymes individually, things like that. But basically you look, if you compare, then you will actually get the difference in bending pattern that allow individuals to be identified. So similarly, because your chromosomes, your contigs, right, is quite long, you can actually cut them with enzymes. They'll give you certain bending pattern, and this bending pattern, 2 different clones may have certain regions that are similar that can be used as an indicator. It's like if you have copies of maps that you want to overlap. That sometimes you see movies where they have different portions of the map to a treasure or something. So one of the things they do is that they try to overlap to get the bigger picture. So this is what they do. All right. Okay. The next section talks about the Human Genome Project. I'll save that for the next video. Bye bye.